left off. We had done some tables to find instantaneous rate of change a couple of times. Just a couple of times. Then this one came up and asked us to find it using the secant slope method. And I don't like this explanation that they've done here. Okay? So after you've seen my explanation, if you want to go back and read this one, that's fine. But I'm about to do this question my own way. Okay? Using both method 1 and method 2. So this is the exact question. I just stole it from that other part of the note. So if you don't have the note, that's fine. Just copy this out. If you do have the note, flip to the back of it or get a separate page to see my version of that example that's there. Their version uses some different symbology that can be confusing. So I'm trying to do a way of doing it that takes all the confusion out of it. It says, find the equation of the tangent line of f at x to f at x equals 3x cubed plus 2x minus 4 at the point -1, -9. Okay, a lot going on here. And let me draw a picture that helps to frame exactly what I'm trying to accomplish. There's some curve. And the nice thing about this method is I really don't care exactly what the curve looks like. I'll never once really need to know what the curve looks like. What I do need to find is the slope of the tangent. And there's two ways you'll know you're finding slope of tangent. One is it might say, find the slope of the tangent. The other way is they'll say, find the instantaneous rate of change. Our method is to do this. We don't have a second point to use, so we pick any point we want up here. And I say any, I do mean any. Any point will do. The closer you get it, the better off you're going to be. And I connect those 2 points. And does anyone recall what that line's called? Secant. The secant finds average rate. This picture's perfect. This completely summarizes exactly what we're up to here. We're going to find average rate using secant slope, and we're going to use that to estimate tangent slope. Now, right now, hopefully you're looking at that and going, but the slopes are a lot different. How are you going to use secant slope to find tangent slope? Wait till you see. Yeah, wait till you see what I do. So what I'm going to do here is I'm going to build my table. The initial point there is -1, -9. That's the point they want me to find the tangent slope at. So what I'm going to do is use some other point Q close by. And find the secant slope between them. How do I choose Q? It just needs to be close. And for the purposes of this example, I'm not going to get all that close. When you go to do them yourself, you're going to be like, why did you start so far away? I'm trying to teach the whole thing. Yeah? When you go to do them, you're going to start really close. So here's my really close point. I'm going to start with an x value of -2. And here's the mysterious part in the whole procedure is how do I get the y value to go with that? It's not difficult, but you have to know this is the part you really got to know. The rest of it will go easy if we know this. How do I get the y value that goes with -2? Yeah, you just sub it in. The equation's there screaming at you. It's saying, if you want y values, just sub in here. You'll get the y value. All right? So you go up there and you get your calculator out. And when I checked last week, everybody had what I thought was a pretty good calculator to do these type of examples. And I type it in. I go 3 bracket. What did I choose? Negative 2. Negative 2 exponent 3 plus 2 bracket negative 2 minus 4. 3 negative 2 cubed 2 negative 2 minus 4 equals, I get negative 32. Then I find the slope of that secant. Now, if you did do some of the homework and their table was a lot more complicated than mine, I've done that on purpose here. I've tried to simplify the table for you a little bit so that you don't have to go through all the little steps that they show there. Slope of the secant. That's just y2 minus y1 over x2 minus x1. Negative 32 minus negative 9 over negative 2 minus negative 1. So what I get here is negative 23 over negative 2, negative 1. I get 23. We really shouldn't write multiple equal signs per line here, but when we're doing tables, we sort of let you away with it. We're like, okay, well, we know what you're trying to do there. So my first estimate of the slope is 23. Now, because it was pretty far away, it might not be a very good estimate. But you won't know until you do a second one. You always have to do at least a second one. Even if you're doing a fast version of this method, you got to do a second one to make sure that this is good. So I'm going to get closer. My initial point is still negative 1, negative 9. But my closer point is, I'm going to get really close here, negative 1.1. I go back to my calculator and I sub in negative 1.1. And I get my y value. Negative 10.193. Now this comes up, how many decimal places? And up till now in all courses and so on, it's always like, oh, 1 decimal place, whatever. What we're doing is we're getting closer and closer. We're going to get really, really close. We're going to really get close to this thing. And if we're going to do that, we got to be really specific, and we got to take everything. Everything. So whenever you get these points, take all the decimal places. I get negative 10.193. Now find slope of that secant again. Now, how do you feel about the first estimate now? It's awful. Of course it was awful. You can see by my picture, if you get very far away with that cue, it's not going to be a very good estimate. But now that you move closer, I've moved the point closer, and here's the most important part of the idea right here is that now that I've moved closer, do you see how that next secant slope is going to be closer to the tangent slope? And as long as I just keep getting close enough, and you're like, how will I know? You'll know. If you just keep going, you'll know when you got it, all right? Any questions so far, though? Because if you get to that far, you've got method 1 down pat. That's all there is to method 1. Find the slope between 2 points and get closer. Summary of the whole thing. So, initial point was negative 1, negative 9. Now I'm going to get closer, negative 1.01, comma. Now, if you haven't done anything else with your calculator in the meantime, you can just go back to your calculator and change all those 1.1s to 1.01s. Pretty easy to do. If you've done other calculations with the calculator, then maybe you have to type it all back in. So there's some refinements to this method coming where you go, why don't I find all the y values right at the start? Then I'll do all the calculations later. And then, so shortcuts like that will come as you practice. Negative 9.11. 0903. Where did I get that from? I mean, let's just rewind a little bit to make sure we're clear. Every time you choose an x value, how are you getting the y value? Sub it into the original. That's going to come up in method 2. We got to really think about what we do during all this. And then I just find the slope again. Negative 9.110903, subtract negative 9 over negative 1.01, subtract negative 1 equals I get negative 0.110903 over $11.0903. Now, that really is showing how bad the first estimate was. But now, the second estimate, I start going, oh, that wasn't so bad. And meanwhile, you're out there thinking, okay, well, you just made us a lot of work by choosing negative 2 on your first go there. There's no way I would choose negative 2 ever again. I'm like, yeah, I know. I'm just teaching them. When you go to do them, you're going to start 1 decimal place away, right? Start a 1/10 away and get closer from there. That is a great, smart place to start. Yeah? However, if this doesn't settle down, you're not done. You got to go until it settles down. And it's not always going to be thousandths that's going to do it. It really depends on the equation. Different equations will have different close ones. Although most of the ones you're given, 3 decimal places will be enough to get the answer. Negative 1, negative 9, 2, negative 1.001, comma. Okay, I got to pause right here. Because to really understand method 2, we have to understand what we're going to do with this now. I've got the x. What are we going to do with the x to get the y? Sub it in. You think I'm being repetitive. Wait till you see something coming in method 2. Okay, so I go back to my calculator. And if you've done it all, if you just left your calculator sitting there, you can go back and get this y value pretty easy just by putting in an extra 0 there. Well, that's a little shortcut for these. Equals negative 9.011 2 O's and then 9003. Keep all the decimal places. I know it's a pain. We need them all. And then to find the secant slope, I go negative 9.011009003, subtract negative 9 over negative 1.001, subtract negative 1. I get on the top there negative 9.011009003, subtract negative 9, negative 0.011009003 over and I get for this one 11.009003. This is the big leap now. Do you know what the answer is? It certainly looks like 11, or at least 11 is going to be a super good estimate of the situation. Yeah? And that's all we're going to get out of this as an estimate. You're like, well, estimate, how do we get the perfect answer? Calculus finishes the deal with something called method 3, which we don't do in this course. I included it in the notes. It's method 3 is in the notes. We don't do in this course. It's really where calculus starts with method 3. But for method 1, at the end of it, you go, okay, I see the plan now. 2 points, find the average rate of change, find the secant slope a bunch of times, and eventually the table will settle down, especially if you're much smarter than me, about picking the points and going, well, I'll just start close, and then I won't have to do this 1,000 times. Yeah? Therefore, m tangent equals, and I'm going to put a little approximately there to say I don't really know exactly what it is. I didn't prove it was 11. I proved it was really close to 11. So the M tangent's really close to 11. This question asks for more than that. It asks for the equation of the tangent line, and I've only found the slope. I'll get back to that in just a second, okay? I'll deal with that after showing you method 2. Because by the end of this, maybe you started off excited because I was excited. You went, okay, this is pretty good. We're going to find instantaneous rate of change. Mr. Todd's wound up. It sounds like it's important. By the end of the example, you're like, this is killing me. Let's do all this table and go through here. Tell me you've got something better. I've got 3 things better by the time you're done with calculus. There's 3 better methods in this. Here, the next method, a little harder to understand. Does the same thing, a little harder to understand, but is much faster. Next method, very hard to understand. Method 3 in calculus. Very hard to understand, but fast. And then there's method 4, which is super fast, but you got to know what you're doing. Okay? And that's what we're doing here. We start off with something that's it's like, most people are like, I totally get it, but I don't have to type this all in. Good, that's fine. And when we're done with method 1, we start on method 2. So to do that, we have to really make sure we understand method 1. Are you good with method 1? The basic plan, at least. Is it good? Okay. A short form version. Method 2. So when I reference method 2 up there, and I'm going to give it a name here in a second. Method 1. Down here, method 1. Table. If you hate the table by the end of the next example, on the test you only have to do it once. In the very first question you do the table, so see I can do the table, and then you can move on and use method 2 the rest of the time. If method 2 is too hard for you, vice versa. You go the other way. You go, okay, I'll use method 2 on this one question he asked me for method 2, and then I'll go back and I'll use the table on everything else that I go to do. Okay. Ready to move to the next page? Next page is the exact same example, except now I'm going to do it a different way. Yeah? Well, it's actually not different. I got to tell you, it's not any different. It's just shortening everything down for us. Here's how I'm going to shorten it down. Same picture. I love this picture. This picture is the same in all the examples. You got your initial point, -1, -9. You got your other point, which I'll deal with in a second. We're trying to find the slope of the tangent, so I'm going to draw the tangent on there in another color. Yes? Trying to find the slope of that tangent, and how are we going to do it? We're going to use some secants. So there's tangent. We're going to use some secants to get this point. Now, here's how we shorten the method in method 2. I'm not going to announce the x value before I start. In method 1, it was like, okay, what x value are you going to use? We're going to use -2, then -1.1, -1.01, -1.001. I'm going to say, I'm not going to tell you what the x value is going to be. We'll put that in later. We'll sub that in after it's all done. So this x value's going to be an unknown to begin with, and that will shorten down the procedure because I don't got to plug it in and do all the plugging in all the way through. I'll plug it in at the end. This is the big tough moment. If you get this moment and the next one, you're going to love method 2. If I've got just some random x that I haven't identified yet, how do I get the y value that goes with it? Sub it in. It's the same answer as I just gave before. Sub it in. And so I sub it in here, but there's nothing to sub in except the x. And so I'm left with the actual equation as the y value. You're like, the equation is the y value? Answer? Yeah, that's exactly what it is. The y value is just this equation. That is the y. Now, I'm going to jump all the way ahead. I'm going to skip over the first column of the table, the second column of the table, the whole thing. I'm going to jump right to a secant slope equation. Watch this. Secant, that's what the name of this method is called. Secant slope equation. Instead of finding all the individual things, I'm going to jump right to an equation to find the last thing. So m secant. Now let's go back and make sure we know exactly how we find slopes. It's important to be able to find, to be able to use this thing. Back to here. It's right there. Let me just highlight it in yellow. To find slope, right there, we went y2 minus y1 over x2 minus x1. Here, my second y value is a big mess. Scary. It's scary when you go to do this. It's a little bit more difficult, but that's what we're after here, is the second y value. 3x cubed plus 2x minus 4. Subtract y1, which is the negative 9. If you just went from happy to headache in one line, then you're in the exact right spot. That should make your brain go, oh, hold on here, what are you doing here? That? And that's exactly the difference between method 1 and method 2. Method 1 is like, yeah, I totally follow everything you're doing there. Just finding slopes, no big deal. Takes forever, but I understand every step of the way. Method 2 is like, oh, you messed me up already. Yeah? I'm not even sure where you're getting this from. All I did, to review, all I did was I said, okay, the initial point, I'm not going to announce the x value, so I just wrote x. And I'm going to plug in the x into the equation to get the y value. But basically, that's the instruction. It says, once you let me know the x, I'll put it here, and then I'll sub it in there to get the y value, once you give me the x. Once you give me the x, I'll take that y value, I'll subtract the other y value. And on the bottom, I'll go, whatever x value you gave me, subtract the negative 1. If we really wanted to, as soon as I finish this example, we could start the calculus course. That's how good this example is. This is the kind of stuff that goes on in calculus all the time. If that freaks you out, don't. You're going to do lots of practice of these. It's going to be no problem. And I'm just going to tidy that up a little bit. That's all I'm going to do. Do you want to talk about my tidying up? Do you see what I did? I went negative 4, subtract negative 9, I got plus 5. And I went subtract negative 1, that's like plus 1. I just cleaned it up a little bit. If you're lost, let me tell you what the secant slope does. I'm going to build the table. I'm going to go, okay, choose an x value. Skip all this. You don't even have to write that in. You know, I'm going to skip everything in between. All this stuff in here, sub it in, negative 10.193, negative 9.11. No. Skip. And jump right to m secant. See, this formula finds secant slopes from x values. You just sub into it and you jump right to here. Let me show you how it works. This is the big moment. I'm going to choose the same x value I did here, negative 2. You think it's stupid. You should think it's stupid. You're like, why would you start so far away? You wouldn't. You wouldn't, except when you're first learning it. I'm going to take negative 2 and sub it in to this secant slope equation, okay? Now, incidentally, if you're not great with your calculator as far as typing these things in, we've got to talk about your calculator a little bit. It's not going to go away, whether it's math, physics, science, biology, it doesn't matter. When you go to type in fractions, rational expressions like this, you need one of two things. And you got to decide in your calculator which one you have. I've got a fraction button on my calculator that does something amazing. Check right now if your calculator does this. If you hit the fraction button, oops, it's just going slow. When I hit my fraction button, I get a fraction on the screen. It's too good. Yeah? By the time this is over, you might be going to the store tonight going, I need a button that when you hit the fraction button, you get a fraction on the screen. Because if you get a fraction on the screen, you shouldn't care about anything I say next. You'll just type in exactly this equation with exactly this x value. You'll just type it all in. You'll type 3 times negative 2 cubed plus 2 times negative 2 plus 5, all in the numerator. Then you go down to the denominator and you go negative 2 plus 1. You're in love with your fraction button. You're like, I don't have a fraction button. Okay, I'm going to teach the rest of the lesson like you don't have a fraction button. Because those of you who have a fraction button don't care. You're in great shape. You're just going to type these in. If you don't have a fraction button, okay, here's how you got to type these things in. It's no big deal. Don't freak out. Good. Okay, if you don't have a fraction button, you have to open a bracket for the numerator. You need a bracket for the numerator and say, here's the numerator. And you type in everything in the numerator. So 3 bracket, what was it? What am I typing in? Negative 2 cubed plus 2 times negative 2 plus 5. And then, oops. And then you got to close the bracket for the numerator. That's how it's different for you non-fraction button people, is you have to open and close a bracket for the numerator. Then you go divided by, and then you got to do the same thing for the denominator. Open a bracket for the denominator, put in the -2 plus 1. Sorry, this calculator on screen is slow and awkward. All right. We got distracted by calculators for a second. You'll get your calculator worked out, or you'll call me over and you'll say, Mr. Todd, how do I type it in on my calculator? And we'll work all that stuff out. That's fine. What I want to show you is what this thing does. I want to go back a page before I press equals, because there's a dramatic unveil here. On the other page, I built a table and I subbed in -2. I skipped over a whole bunch of stuff. I put the -2 in my fancy secant slope formula, and when I press equals, do you see what it does now? It goes from here to here. It goes, take the -2 and jump all the way from here all the way to the end answer. Much faster to use. It might be twice as fast. You'll do the questions twice as fast. But it's a little more complicated, and that's the progression all the way along. Method 3 at the start of calculus. A little more complicated, much faster than all this. Method 4, fast, fast. You can do calculations like this with this idea. However, you got to know what you're doing. That's what advanced functions is. It's like, let's make sure we know what we're doing first, and then we'll jump into the calculus pool next quad, right? Okay, back to here. Back to this one here. -2, skip all this. Answer 23. It gets better. You're like, well, yeah, but that was a lot of typing. There's still a lot of typing. Come on, you didn't save us all that much typing. I'm like, watch this now. I'm going to get closer. What was the next one on the other table? -1.1? All I do is go back to my calculator, especially you fraction button people. You'll be in great shape. You just go back and change all those -2s. Just change them to -1.1s. I got to use backspace on mine. You got to get to know in your calculator what you got to do to get -1.1. All the -2s. I think it happens 3 times. So I got to go back here and get rid of -2 and type in -1.1. Some of your calculators type over nicely. Some insert nicely. It depends on the calculator. You'll just have to work that out. And just in case you've drifted off to sleep on me, let's go back to that original table and have the dramatic unveil again. I've changed all those to 1.1s, which was the next thing I did in the table here. I chose 1.1 next. I'm going to move that over there. I put in 1.1, and on the table method 1, sub it in, put it into the slope formula, subtract, then divide them both, 11.93, and by the end of it you're like, I hate this. Method 2, jumps right to the end. Am I doing a sales pitch for method 2? Oh yeah, I am, for sure, because I know you need it for calculus. But for chapter 2, actually, if method 2 becomes difficult for you, and by Wednesday you don't got it, you can do all the questions, except 1, using method 1. Question 1 on the test, show me method 1. Question 2 on the test, show me method 2. Then a whole bunch of other questions where you go, do whatever you want, yeah? Whatever's best for you. Back to this one, my calculator, 11.93. And just like the other table, you're like, okay, that's not good enough. Obviously, 23 wasn't a very good estimate. 11.93 was better. I go back, and those of you, and right now is the moment where you go, I am never choosing -2 again. It'll always be 1 decimal place, because changing 1.1s to 1.01s, at least on my calculator, is the easiest thing ever. Because on my calculator, I just arrow back, and every time I see a 1.1, I just put 0 there and move that over. Now, if your calculator does everything I'm saying, except it doesn't move that over, look for the insert button. It'll be an INS button, and actually that will allow you just 1 extra keystroke to just insert a 0 there. And this doesn't have to take nearly as long as the way I've been showing it when you actually go to do it yourself. Equals 11.0903, is that what I got on the other page? When I went negative 1.01. And then I think I went one more. Negative 1.001. I'm just going to try and move that all up so you can see it better. Did I grab everything? Oh, I like that. Negative 1.01. I'm still skipping all this. I'm not doing all that stuff in between. Back to my calculator. Show you once again. Adding a 0. At most, you got to hit an insert button. Equals. And I get what I got in the other one. 11.009.003. How are we doing? Making this equation, not really simple, but it follows the same pattern every time. You write x, comma, equation, and then you go y2 minus y1, x2 minus x1. Tidy up a little bit, if you can. A little bit of tidying up certainly helps. Yes, he said lying. Yeah, we could go one more step with these where you go, find the point that gives a certain slope. And we will get to stuff like that. And I'm not saying there wouldn't be one maybe in a homework question somewhere along the way. We don't really ask that question in Unit 2 here. But yes, that's where this is going, is like, maybe I won't even know this point and I got to use an x and something here. One step at a time. Those things aren't that hard, but you got to get this part down first, and then you go one step further along the way. And really, you're actually bumping into what's called method 4. You know, it's not called method 4, but we sort of reference it that way. So yeah, you're right. There's more steps to go here. So for now, I'll tell a big fat lie and say, no, you'll always be given this. Yeah? And then we'll progress on from there. Other questions? That was a beauty. It's a perfect question. Other questions? They do that exact example at the end of theirs. You can now ignore it. If you're like, well, I like yours, I understood what you were saying there. They did that exact example in the note with some different symbology. They basically did the same thing that I did. Okay? Now, just to go back and finish that off though, both times now, I think I've got a good estimate for the slope of the tangent, which I'm going to use approximately 11. You don't have to put these approximately in this course. I'm putting it there just to remind you that technically we haven't proved it's 11. We've proved that we think it's really, really shocking close to 11. Okay? Now, let me just review the information we have, because they asked for equation of the tangent. There. So, one more little thing to do here. We have m tangent equals 11. I didn't put approximately here anymore. I'm going with 11. I think 11's real close. And p of, what was the original point? -1, -9. The rest of this is a grade 9 problem. And I don't say that to be condescending. I just say, now I'm going to try and scrape some rust off your brain and remind you, how do we find equations of tangents, or equations of lines, when we're given slope and a point? Okay? Therefore, the equation will be y equals mx plus b. All lines have the equation y equals mx plus b. Does that ring a bell underneath all the rust in your brain? Oh, yeah. Y equals mx plus b. Here it comes. This is why we beat y equals mx plus b to death way back when, is because we need it right here. But we have m equal 11. So I get y equals 11x plus b. I use capital B's because my little b's look like 6's. So I always use the big B when I'm doing y equals mx plus b. And does anybody remember now what to do? Y equals 11x plus b. I knew what the slope was 11, but I don't have the b, the y-intercept. How do I go about finding that y-intercept if I know the slope is 11 and it's got to go through this point right here? How do I do for my random point? My no-look point, I try to do the no-look point. Just sub the point in, yeah? So sub in -1, -9. your grade 9 and 10 teacher were supposed to beat that to death. But if not, I'm showing you how to do it here. Negative 9 equals 11 times negative 1 plus b. A little bit of algebra there. And b equals 2. A couple people on the test tripped up on this kind of algebra here, just solving for x, just one missing variable like that. So if you had that trouble, we need a little brush up on that because we got to be pretty good at just solving for one single variable in an equation. Therefore, y equals 11x plus 2 is, plus 2, not plus 12, is the equation of the tangent. Why do we care what the equation of the tangent is? The equation of the tangent shows where this thing would go, where it's headed towards at that particular moment. And it has huge applications in every branch. Chemistry, biology, physics, economics, computer science. Everything has an application of equations of tangents. In fact, chemistry people have already seen secant and tangent. She had to gloss over a little bit because she didn't have all this yet. Wouldn't you love to retake that? Those lessons would now be so much clearer now that you've seen all this. Question? Yeah. So this page is good for method 1 and for method 2. That's why I waited till the end to finish it off. So you should watch out for that in the test, right? If I say find equation of tangent, it's awfully tempting just to find the slope. In fact, I almost did it just a couple minutes ago. I got talking so much. Okay, slope's 11. Oh, I did it. Oh, that was tough. Method 2. Okay. All right. Next question. Meanwhile, the question's gone. Find equation of tangent. So that's where the highlighter's good when you're writing tests. As you read the question, I go, oh, I'll just highlight that. And then before I go hand it in, I'll just scan through and make sure that I answered all the questions. So frustrating. So frustrating to get tests back and go, in fact, somebody did it on the last test, I think. It said, graph something and it's inverse and the person didn't graph the inverse. Come and see me if it's you. And maybe we'll talk about it, okay? Where they graphed what I asked, but didn't graph the inverse. Either didn't read the question or forgot by the time they did the graph, okay? Any other questions about that?